We're looking at number 3 and 4. They want us to solve for x for both of them. So what we have here is we're working with sine. So we have the value of sine degrees is equal to the opposite side over the hypotenuse. So we want to make sure this follows the rule. The sine of x just represents the degrees. So we have the opposite side, which holds true, and we do have a hypotenuse, so that also holds true. So for this problem, we have the sine of 62 degrees is equal to the opposite x over 12. I want to isolate my x, so I multiply both sides by 12. 12's cancel. I get x is equal to 12 times the sine of 62 degrees. From here, all we have to do is click 62 sine times 12, and we round to the nearest tenth, so it will be about 10.6. So for number 3, we get x is equal to 10.6. Now let's jump down to number 4. Number 4, again, this is a sine assignment. So we have sine of x is equal to opposite over hypotenuse. When I see this right here, I need to know what I'm doing, so I put my pin on the angle. Good, that 10 is the opposite side, so I can use this function of sine. And then I have right here the hypotenuse, so it works out. So right here, the sine of 24 degrees is equal to 10 over x. From here, all I have to do is I need to isolate x, but I have x in the denominator. So the first way to get it out of a denominator is multiply both sides by x. So we get x times the sine of 24 equals 10, but x is out of the denominator, but it's not by itself. So now I have to divide by the sine of 24 to both sides. We get x is equal to 10 divided by sine of 24 degrees. So the rest of this will be our calculator doing the work. So I'm going to cover this just so we can see how I use the calculator. So it's going to be 10 divided by 24 sine, and 0.4 does not make sense, so you have to click equal one last time. And if we're round to the nearest tenth, it'll be 24.6. So x is equal to 24.6.